The topic of the lecture is geomembrane in hydraulic works. Carpi, I'm the technical director of Carpi Tech. Carpi Tech has been founded in 1963, and since that time, we have completed almost 400 hydraulic projects in the world. I just wanted to focus on the 214 dams waterproofed with a geomembrane, rehabilitation or new construction, 58 reservoirs, 50 canals, and 25 hydro tunnels. I will touch during the presentation all these four main topics. I will leave apart the traffic tunnels. There are another typology of projects, but perhaps less interesting. So Carpi is based in Switzerland. I'm talking from Switzerland right now, from the south of Switzerland, Ticino. We have in-house technical department. We are all around the world, actually in 23 international entities and about 120 employees in the world. We provide turnkey solution. What does it mean? We provide from A to Z, design, supply of materials, installation with specialized technicians, quality control, and warranty. Our office, I said, is in Switzerland, but we have some poles or hubs with management people there in Canada, United States, in India, where we are very active, you will see in the presentation, in Peru, that is actually controlling Central and South America, in France, where we have another bunch of interesting projects, especially in rehabilitation. And as I said, a technical office that I'm very proud of this, because we can say that we are not just a supplier, as sometimes happens. We are not just an installer. We are a contractor, a professional contractor dedicated from A to Z, and including the design of the waterproofing systems. I have with me about 6-7 people working in the technical department and managing, and they are all really great professionals. Carpi is also very active in research and development. We continue to develop, to improve our research every day, believe me. We have an in-house laboratory. That means that we have a warehouse where we have some devices to test the membranes. For example, we have pressure chambers where we can stress the membrane on particular configuration and subgrade up to 200 meters of water head. So in the research, we are focusing in the very last period on special application of geomembrane underwater. You will see in the presentation. So that means that we can install the geomembrane with divers, and that we are developing system to connect together the geomembranes in a watertight manner, using, for example, zips and mattresses. Backward, forward. Yeah, we have working teams from all around the world, and we send to a specific project the team that is most suitable for the legislation of the country, the climate of the country, and the expertise required by the projects. We are used to manage very large crews, also with partners, not just alone. The photo of the big group on the bottom right photos, for example, is a canal project in Indonesia, where we were more than 300 people working there. At the same time, the same canal isn't part of the presentation. So now I go to the main topic, and sorry to taking time just to present where I work, but this is probably something very interesting. Also, if in the future you may have questions, you can always contact Carpi, and we are available to give you further input after what you are going to listen in this presentation. So properties and design aspect of a geomembrane sealing system. The photos here, for example, is one of the testing apparatus that we have in our in-house laboratory, is a pressure chamber. So the properties, we're talking about application of geomembranes in hydraulic works. So there are some specific properties the geomembrane must or should have to be applicable for hydraulic projects. For example, I listed flexibility to follow the deformation and settlement of the subgrade, and also add the connection with the rigid structure around, for example, the canal reservoir of the dam. Durability, evidently, we need to provide our clients with a product that is long lasting, so that it has a service life compatible with the project requirement. And this has been proved. The modern formulation of the geomembrane is not absolutely uncommon to provide a service life exceeding 50 and reaching potentially, theoretically, 100 years of durability, more than my life, but that's okay. It's a durability in terms of theoretical estimate. How we estimated this with accelerating aging test, for instance, but today for another instance, we have a dam with 45 years of operation in the Alps here in Italy. So this is also proven by live projects. Steady performance in hot and cold climates, and also aging compatible with the hot and cold climates, puncture resistance of the subgrade, adaptation of the subgrade shape without development of stress concentration, resistance to impact, abrasion, and friction with floating objects and sediments. This is typical of a canal installation. Resistant to placement of a cover layer, because sometimes is required, so cover layer on top of the lining system. Low response, so I would say good behavior in terms of retaining development of folds and wrinkles to have a smooth, flat surface for the lining system. High friction with the subgrade, with the interface, to install the liner on a steep slope, for example, like the reservoir slopes of a pumped storage scheme, where the membrane should stay stable without developing folds and wrinkles because of the self-weight and the sliding on the subgrade. Versus exposed versus covered solution. Yeah, I know this can be a critical aspect. In Carpi, we always promote an exposed application, fully exposed whenever possible, when there are no risk of vandalism, where there are no requirements dictated by impact of object, rock, falls, or similar hazards. Why exposed? Exposed because the membrane can be controlled during installation and after, during operation, always, in the dry, underwater, so monitored in the behavior. Repairs can be planned to check that the membrane is in the integrity of the membrane, and also the possibility to repair the geomembrane when a damage, a perforation, for instance, is detected. By statistic, it's very common that the construction of a cover layer actually is the cause of the damage in the liner, because of an imprudent application, the workers walking on that, or the application of a concrete pouring or rebars or whatever that can be a sharp element for the liner. So this is a paradox, but sometimes the cover layer produces more damage than what is supposed to protect. Then the repairs of a lining system or geomembrane in general is very quick. And this is a big benefit when I have to present to my clients a comparison between geomembrane, for instance, and concrete facing or asphalt facing, because the membrane can be repaired in minutes. That's a reality. Can be repaired even underwater. So it's a solution that is very flexible, not only because it's flexible, the material is, I'm playing with the words, but because the material has the flexibility to follow the requirements of an hydraulic structure. Then we typically in Carpi promote the use of a composite geomembrane that sometimes is referred like as a geocomposite. Geocomposite is a membrane that is thermally bonded during fabrication to a non-woven geotextile, a backing geotextile on one side, or also on two sides in sandwich. The geotextile will provide to the membrane benefits in terms of mechanical properties, especially puncture resistance, but almost also thermal stability, more resistant to tear, more resistance to pull, so to tensile stresses. The geomembrane selection is a very critical aspect in an engineering project. So first of all, the membrane must be selected looking back at all the points that I listed before, but also having in mind what is the REX, the return of experience, what are the previous projects. So we have the ICOL bulletin, the 135 issued in 2010. Now, unfortunately, it's quite old, and we are promoting ICOL to start building a new one, more recent, with the new technologies or nowadays technologies. But already in this bulletin is listed that the 60% of the dams waterproof with the geomembrane liner are waterproofed with a PVC liner. There is no good lining system and bad lining system. There are membranes for a specific purpose. So there are membranes of polyethylene, very good for sort of application. There are bituminous membrane, very good for other application. There are PVC membrane, very good in hydraulic application specifically, and in exposed position. For example, the 3 pump storage projects today under construction in the world, Pinapuram, Gandhi Sagar, Chitravati, and 3 that have been completed in the last 5 years, Cayeta or Pico da Urze in Madeira Highland, Abdel Moumen and Kokhava Yarden in Israel. Abdel Moumen is Morocco. All of them have been waterproof with a PVC membrane. So it's statistic, but it also, as I said, a very strong return of experience. So the ICOL bulletins, I suggest you to ask a copy to ICOL if you don't have, contains a lot of information about the requirements and also the guidances to select the best liner, but also with details of installation procedure and arrangements for connection and anchorage and drainage of the liner. What is really important for me is having a very efficient drainage system, a very efficient anchorage system, a very good quality control. Warranty is a plus, and Carpi, for example, is providing a plus. That means that we put our face in the project, we put our business in the project, we risk our money in the project because we cover potential liabilities with a warranty. So we provide a system that is warranted in terms of material and installation. So I would say performance. Let's talk a little bit about environmental loads. So this is another crucial aspect, together with the selection of the proper geomembrane for a specific project. The membrane in general has to resist applied loads, so has to be provided with an anchorage system. Which kind of loads? There are wind uplift loads, subgrade stresses produced by puncture, burst, bridging and differential settlements, action of floating debris, for example, action of the ice on the membrane, environmental load like high temperature, high UV, freeze and tow, cold exposure that can affect the flexibility of the membrane. The same impounded water is transmitting load through waves, currents, chemical composition of the water, and back pressure is another important and crucial aspect of the design. So controlling the water behind the membrane to avoid the uplift because of a back pressure. The wind uplift is probably the most known, so the one is on which we focus the most, because the anchorage system prevalently is designed to resist the wind and the water uplift. They are almost equivalent, but they produce a pattern of stresses that can uplift the form and damage, seriously destroy a geomembrane liner. So we made with the Polytechnic of Milan, we follow the literature, of course. We follow the available formulas, procedures, and results that are available in literature. We have done our own research with the Polytechnic University of Milan in a wind tunnel to confirm the values proposed by the literature, to investigate more in detail how we can optimize the anchorage system, knowing how is the behavior of the wind on an embankment dam, for example, that is the common configuration of a pump storage scheme or a dam of whatever type. And with this research, we are proud to say we have a deep knowledge how to manage the anchorage, the design of the anchorage system. Together with the test that we are doing in our in-house laboratory, where we stress the membrane on very aggressive surfaces, for instance, it is common practice when we have to install a geomembrane on a granular material subgrade in a reservoir or on a dam, rockfill dam, for instance, or earthfill dam. So we stress the membrane on an aggressive subgrade under pressure. We can also apply cycling loads, so to remove and apply the water pressure to simulate the behavior of a pump storage scheme. So this is very important because we take care of the assessment before installation, before design, and of the expected behavior of the lining system to prevent unexpected, unpredicted behaviors that will require adjustment of the design. So we start with the right foot, and we wanted to have a deep knowledge of what is the expectation of the liner and the potential loads the liner has to sustain in the real life. Sinkhole development has been another very interesting recent project that we are following for a client in Canada, where they have a canal with sinkhole formation and they want to apply the liner to prevent the water to infiltrate and develop at the sinkhole. And we simulated the occurrence anyway of a sinkhole under the liner to check the capacity of the liner to resist the burst stress and to keep the load of the water pressure into the canal even without any support underneath the geomembrane because of the formation of a cavity. All of those tests that looks like extreme cases can actually be a real event in the application of the geomembrane. I'm not saying that all of those events has to be, let's say, taken in the real life. So we have to design to prevent the occurrence of such stresses, but we have also let's say the need to check what could happen to the lining system if those extreme events can actually happen, and how is the behavior and the potential failure mode of the geomembrane system. Since we have to remember that behind a geomembrane liner, there is always a very critical infrastructures like a dam that has to support, for example, a very serious leakage through the geomembrane. So multi-axial bursting tests are the equivalent almost of the previous one to check the capacity of membrane to expand and support certain pressure applied by the wind as a suction or by the water, like a bursting into a cavity. And then let's start talking about projects. And I have several topics to touch. The first is the application of geomembranes in rehabilitation of existing dams. I will pass through also new dams construction, tunnels, canals, pump storage scheme as quick as possible because we don't have much time, to be honest. Carpi, the design concept that we follow when we have to remediate leakage or deterioration of an existing structure is, of course, to create a new watertight barrier, because the most of the cases we have to prevent the water to continue infiltrated into, for example, a dam structure. So the liner usually is installed exposed for an inspection at any time. We need to design an anchorage system. We need to design a drainage system under the geomembrane. We need, depending on the type of support, we also need to bridge joints, construction joint, expansion joints, cracks in the structure. So we have to design an additional layers, because usually this geomembrane sealing system is not a simple membrane. It's a sum of different layers that can include a geomembrane, of course, a geodrain, a supporting layer, a cushion layer, a protection layer if we need a cover layer. So there are multiple elements that form the geomembrane sealing system. Repairs of existing dams typically have a drainage that you see in the photos is a synthetic drainage material installed under the geomembrane directly on the structures. That can be a biplanar, triplanar, monodirectional, bidirectional drainage geonet with high compressive resistance and high flow capacity that will control and evacuate specifically, if of course possible, by gravity, the water toward the bottom, where this is conveyed to the, if existing gallery inside that body, or by perforating through the dam body, exiting downstream. Typically, actually, we connect the geodrain to an internal gallery in the dam structure. So the geomembrane that we typically use in this kind of project as a brand that you may have heard before is called Sibelon, is a PVC geomembrane, specifically formulated according to a recipe that is protected by intellectual properties, that is a property of Carpi, but essentially is a PVC geomembrane with a special formulation. This membrane is applied on the face of the dam and needs an anchorage system to retain the loads. We have patented in the past, and now the patent is expired, but it's still a signature of Carpi, the tensioning system that is, we call them tensioning profiles. They are an assembly of profiles of stainless steel that together can provide to the geomembrane two effects. One, of course, anchoring the membrane against the wind loads. But second is also to prevent the formation or eliminate formation of folds and wrinkle on the geomembrane surface. That at the very end, the geomembrane will look like straight and smooth. The folds can be detrimental for the liner. And this is why we want to prevent them, because the liner can be, the folds of the liner can be squeezed by the water pressure. It's false to think that the water, being colder than the higher ambient temperature, will just shrink the geomembrane and eliminate the folds. This is not a reality. When the water will get in contact with a fold in the liner, for example, for thermal expansion or self-weight on a vertical face, the water will squeeze the liner and will cause a concentration of stresses. This can be also caused by a cover layer, actually, of soil. And the squeezed folds are a point of accelerate aging and stress for the liner that we wanted to prevent. And this is how it works with the two assembly together coupled to eliminate the folds. Some photos of quite a recent project in Chevrolet Lake Dam in California, Lago di Mezzo in Italy, that was performed in 2004. Alpegera Dam in Italy, 1994, so an old installation. Lago Nero Dam, our record installation, 1980, so 48 years of operation today, still in operation with no maintenance. The liner, like in this case in Chambon Dam in France, geomembrane liner, can also be used to mitigate the progress of the alkali aggregate reaction. In this case, in Chambon, there was a combination between structural rehabilitation with tendons, with fiber strips to connect the tendons, so pre-stress the dam from upstream to downstream, so crossing through the dam with the tendons, and finally installing a geomembrane liner on top of the upstream face to prevent further passage of water or, let's say, saturation of the dam body. That can, of course, is one of the first cause of the progress of the alkali aggregate reaction. So Mesuri dams can also be another case study. Mesuri dams are actually designed like a concrete gravity dam or an arch dam, but they have the particularity to have a very irregular upstream face with, let's say, block of stones forming the masonry. So in this case, typically we have to add a geotextile to prevent the perforation, to preserve the mechanical properties and the longevity of the liner without concentration of stresses on the protrusions. This is very typical. In India, we had a project that here is in the picture, Upper Bhavani. They have a lot of masonry dams, but it's also common in Europe and in Portugal as well. The liner is really an engineering and sophisticated application in this type of rehabilitation works. And in fact, Covao do Ferro Dam in Portugal in 2005 has been waterproof exactly with this technology, including a cushion geotextile and a geomembrane lining system made of a PVC geomembrane. As you can see on the right photos, there has been the need to regularize the masonry surface very regular with some mortar strips in correspondence of the tensioning profile. So the vertical fastening lines for the geomembrane liner design, of course, to prevent the formation of faults, but also to retain the geomembrane against the wind loads. Multiple arch dams is another application. We made several projects, for example, in France and in the USA, like Panessier Dam in 2012, Rockfill that we completed just 1 year ago. If you see the photos of Rockfill, is impressing to me, at least, the complexity of the scaffolding system that has been designed and erected to allow the installation of the geomembrane. But typically we use suspended swing stages or nacelles to access a vertical face or a very steep inclined face. And this is an application that is, I would say, very suitable for a geomembrane because of the complex geometry of the arches and the possibility for the geomembrane liner to adapt to very complex geometries, to tailor the liner on the asperity, on the irregularity of the geometry, and to create a suit like is a tailored solution for complex geometries. We had also recently in 2019 an application of a geomembrane liner to rehabilitate a concrete face or rockfill dam, or the dam of Paradela. Repair of concrete facing dams, it's another, let's say, core business for Carpi. And you will see that we have developed an alternative to this kind of design. The rigid structure of the slabs tends to crack, and the geomembrane is definitely suitable to cover and protect and avoid infiltration through the existing cracks in concrete face slabs. Typically, we have a liner for drainage, a liner for cushioning, and a layer for waterproofing. Okay, other example where this is just meaningful because Ober Dam has been requested to be partially exposed and partially covered. So the upper part of the dam, for a high static reason, also for the contact with the ice formation during wintertime, has been protected with a masonry that has been applied directly on the geomembrane and has been supported at mid elevation, as you see, with some metal structures bolted through the liner and into the underneath concrete face. Repair of asphalt facing rockfill dam is another important business for Carpi because asphalt, similar to concrete facing, tend to crack, especially when there is a large excursion between a hot summer and cold winter, and the asphalt is really a living matter, so expanding and shrinking, and by aging with these stresses tends to crack and spoil. So again, a membrane sealing system provided with a geotextile for cushioning, a geodrain for drainage, and a PVC liner for waterproofing is definitely suitable. And a tensioning system, as in the right top photo, tensioning profile system, is very suitable for this kind of application. In some cases, we also have developed a system for anchoring the geomembrane without tensioning profile, so without bolting through the asphalt, because perhaps the asphalt was very thin. And in this case, we used geomembrane strips embedded into grooves, so cut on the asphalt, and then pouring our resin compatible with the bitumen, we finally embedded the membrane into the face, the strips into the face, and then the geomembrane, by welding the main liner on the strips, has been provided with an effective anchorage system. Underwater application as something we promote with our clients anytime there is a critical issue with the watering of the reservoir, or maybe the reservoir cannot be dewatered. In some cases, because there is no bottom outlet or no working bottom outlet, or a bottom outlet located at a high elevation with respect of the ground at the upstream phase toe. So in this case, the only solution to rehabilitate the dam is to install underwater. In some cases, this is very important. Application of a membrane underwater means not stopping the plant, not losing the valuable water, not depleting the reservoir. And by doing this, sometimes the cost of the loss of production and the cost of discharging into the river the valuable water can be much higher than the cost of the geomembrane lining system installed underwater. Underwater, the system is actually at the end of installation absolutely similar to the installation in the dry. Of course, there is a complexity in the installation underwater that will require special equipments like the rolling machine, like diving tools, like special engineered application and configuration. But the final results looks like exactly in the dry in terms of aesthetic, that is less important, but most of all in terms of performance. So at the end, the reduction of the leakage in repairs in underwater and in the dry can be equivalent. It's different, the cost, but I want to promote the thinking of what can be saved by retaining the water in the reservoir, continue the operation of the reservoir while installing the geomembrane. It will take a lot of time, of course, because the divers underwater cannot move as fast as in the dry, the workers. But at the end, the benefits can be really valuable. Studena Dam, for example, has been a great success for Carpi in 2018, and we waterproofed the full dam face from crest to bottom of this strategic resource of water for the city of Sofia, downstream, the capital city. And the membrane has been installed completely, together with the surface preparation, so also the cleaning of the surface, the repair of the spawning parts, underwater with divers. New embankments. I told you one of the core business of Carpi is repairing concrete face rockfill dam. So at a certain point of Carpi history, there was the advent of a new technology. Replace concrete facing, replace asphalt facing with a geomembrane facing. So stop installing a product that will deteriorate the crack and has to be rehabilitated, especially on a very deformable subgrade, with something flexible. That is a very straightforward logic. So new embankments, rockfill or earthfill embankments, with only one sole waterproofing element made of a geomembrane liner. For this kind of application, the anchorage of the geomembrane is paramount, and it's paramount to have an anchorage that is flexible, is flexible the lining system, so a dynamic anchorage. And we have developed in Carpi several patented solutions to anchor the geomembrane. The subgrade for the installation of the geomembrane can be made by several different materials, granular coarse material like gravel and small stones. Sand can be clay, can be also extruded porous concrete curbs. I will explain better what is this, but it's something that has been widely applied in design and construction of new geomembrane face or rockfill dam, and that can allow to have a very steep slopes faces and reduce the volume of the embankment because of the steep faces, and can provide a subgrade for the geomembrane, very stable, long lasting, more than the membrane, definitely. So the membrane can also be replaced in the future on the same subgrade. Porous, so permeable for the water to control the leakage, to control the subpressure, fast construction, and allow also the installation of geomembrane in stages. That is a big benefit because staged installation, so lower part first, medium part second, third part, maybe 1, 2, 3 stages, can allow early impoundment. Early impoundment means that we can start filling the reservoir when the construction is still ongoing, when we can start commissioning of the turbines, for example, in a pump storage scheme or hydropower plant. When the dam is not completed, this is the case of Rogun Dam in Tajikistan, where the main dam is under construction, 300-meter high, and the coffer dam with a Carpi membrane is used today to generate energy. So they are producing energy with the coffer dam that will be embedded into the final shape of the main dam in the future, that is a clay core dam. So how it works, this system, the curves are extruded with an extruding machine, like the curves of a roadside, a pedestrian road. So those curves form a facing on the dam face. Those curves, I said, are permeable, so the water will not accumulate under the line and will permeate through the curves, and the leakage is controlled and the subpressure is controlled. The membrane is installed directly on the curves. There is no need of surface preparation. There is no need of trimming, post-compaction of the face made of granular material, because this surface is very stable and will remain stable even under the earthquake shakes, the waves, the water currents, the transit of the workers during installation. The anchorage is made with strips of geomembranes embedded, placed overlapping the curves and forming vertical anchorage line, outlined in the right bottom pictures. And finally, the geomembrane is installed on the face and connected to the strips to create a dynamic anchorage systems. As you see in the left picture, this installation in Namu 6 Dam in 2015 has been done in 2 stages. That means the lower part and the upper part, and the lower part was under installation while the dam was in progress, rising the dam in the 2nd stage, so without stopping the construction of the dam. Then we have the meaningful case of Las Bambas tailing dam in Peru, ongoing today. The dam today is 186 meter high, made of rockfill with extruded curves. And it will be in the future 230 meter high, even if some designers are thinking to build and rise more in elevation. This dam is waterproof with the geomembrane PVC line system and with the technology of the curves and anchor strips. We are proud of this installation that is absolutely meaningful. 4,000-meter elevation in the Andes, in the inner part of and more than 1 million square meter of membrane today. Santa Maria in Mexico, Singrobo, Edevu, those are all of the same type, are geomembrane face rockfill dam. And Edevu, 90-meter high, probably is one of the most recent, together with Singrobo in Côte d'Ivoire. Pump storage schemes, I have to accelerate a little bit. Then let me check one thing. I have a bad surprise. I have 13 minutes and my computer never reboots. So, but don't worry, I will move to the computer of my colleague to continue while I'm rebooting my computer. The IT, I'm sorry, it's a problem. Okay, let's go back to the presentation. Okay, pump storage scheme. Is my screen? Okay, pump storage scheme. Oh, why is not moving? Sorry. Okay. Pump storage scheme. Today, I want to be honest. The most, I can hazard to say, all the recent pump storage scheme in the world, not using existing structure like existing concrete dams or so. The recent one, the one built from scratches, are all considering or have been built with a geomembrane liner. Is the future, is the most flexible application for this kind of structure, because those structure needs two main factors. One, a fast installation to reduce the construction time and to start early impoundment, early commissioning, early turbine generation. So geomembrane liner is fit for purpose. Second, they are made of granular material, so rockfill or earthfill. So they need something flexible, something that can allow to follow the formation, to be really suitable for the type of structure. So in this case, the membrane is applied as an in-exposed position, typically. Is applied on a granular subgrade. In some cases, is applied also on extruded porous concrete curves, like in the design of a geomembrane face rockfill dam, because the most of the pump storage scheme actually they include a dam, a rockfill dam in the scheme. So they can be partially in excavation, but partially in elevation. So they are actually surrounded by a dam in most of the cases. So a particular aspect of the pump storage scheme is that the water is fluctuating up and down with a cycling displacement every day, even 2 times per day. So it's a cycling load to the geomembrane. So not only the membrane has to support the formation and bursting and puncturing, but all those loads and also the wind, all those loads are cycling loads. So they can happen in several cycles, and they can have very different loads on a geomembrane, because a static load is not like a dynamic load. Dynamic load can cause fatigue. And fatigue has to be prevented by studying an anchorage system, a subgrade preparation, a cushion linering that is suitable for that kind of application. The service life in this kind of project typically ranges between 50 to 100 years. So also the geomembrane is demanded to be very long lasting. And the anchorage system is exposed to loads probably more intense than other type of structure. So it's very important to design the anchorage system for pump storage scheme with specifically in mind the cycling load, let's say a large portion of the dam that can quickly be available for the pressure pattern of the wind in lifting the geomembrane, and also for the water currents of the rising and lowering water level. So the subgrade preparation is paramount. The drainage system is paramount as well. So a network of pipe, trenches, a blanket, a synthetic geodrain is very, very suitable for this kind of application. Since the subgrade is deformable, the connection to the rigid structure like the intake tower, bottom outlet, spillway, overflow spillway for emergency is crucial, because there is where we can have a differential settlement. So is where the geomembrane can pass from a flat configuration under the installation to a step installation under the water load. And this is a stress concentration. And this will cause the failure of the geomembrane. So specific technical solution must be designed to prevent the membrane to get in tension at the contact with the rigid structure. So there are specific idea and concept to provide to the geomembrane extra lengths, to provide folds, to provide a geometrical configuration, to avoid, actually, we have to not only to mitigate, but we have to prevent the formation of localized stresses. The drainage system is again paramount in pump storage scheme. Why? Because Water can infiltrate. It's unavoidable that the membrane, like all the material of the walls, they have leakage. That can be small, definitely, but if you have a localized puncture for the impact of a stone, for instance, you can have a higher flow in that specific spot. And this water can go behind the membrane, can create an accumulation, can create a sub-pressure, and the water is passing from full load to depletion to the lowest operating level in hours. So it's much more than a sudden drawdown, like we used to say for a dam. In a pump and storage scheme, they work really at a fast speed that is not comparable to any other kind of structure. So the drainage system is paramount and vital. The water must be controlled to prevent the uplift and the displacement of the geomembrane for accumulation of water underneath. Pico d'Aur's Caieta pump and storage scheme is one of the most recent we have completed in the last years. We installed 82,000 square meter of membrane. Originally, the project was designed with an HDPE liner and then has been changed into a Carpi PVC composite geomembrane after a technical expertise. I have to accelerate a little bit. Pinnapuram pump storage scheme, 500,000 square meter of membrane installed in the upper, lower reservoir, approach channel, tail pool, and intake pool. This project is very meaningful because it is a complex with several green energy solutions. So there is a wind farm, solar farm, and a pump storage interconnected together to provide green energy. In fact, the company is called Greenco. In India, is probably together with Adani, one of the most important power supplier. Geomembrane can be installed, in this case, using trenches for the anchorage, trenches that can be carved out from a porous concrete subgrade, not properly, in this case, that is meaningful, extruded curves, because we stepped into the project when the dam was already built, so there was no possibility to start with the curves on an already built dam. So we designed a skin on the upstream face made of porous concrete, where in the negative portion we created trenches, backfilled with the same porous concrete to anchor strips of membrane for retaining the main liner. Very nice photos of the full complex. Today is under commissioning. Gandhi Sagar is similar. It's another Greenco project after the successful experience of Pinnapuram, but here we stepped into the project at the beginning. So we were able to change the original design into something suitable for the accommodation of the extruded porous concrete curves. And in fact, this is as you see, is a huge ring of kilometers, 6 kilometers, a 30 to 40 meter high embankment. All this made with extruded porous concrete curve. They bought 6 extruded machines to go fast pace and to follow the erection of the rockfill dam. So canals is another application of a membrane. Canals that can be waterproof with an exposed liner, partially covered liner, typically on the bottom where there is the need for the vehicle to circulate. Fully exposed, that is very common. Covered with concrete, covered with the granular material, but again, like in the other projects, here we have some special focus on the anchorage. And I want to say that the stress induced by the water can be much higher than the stress induced by the wind because of the density, of course, of the water, so the kinetic energy transmitted by the water. So the lining system has to be designed with a very competent anchorage system, drainage system on the back that can be made of a free drainage with pipes discharging outside the system, but in some cases with valves, because there is no possibility to discharge outside the system, so we have to discharge inside, especially with the rehabilitation projects. So discharging inside the system when the water is is depleted into the canal, means to discharge in with a valve that is a one-way valve. So the water can only go in one direction and they stay sealed during operation. One of the benefits of a geomembrane lining system in a canal, not only, of course, is stopping the water leakage, preventing the deterioration of the concrete, or preventing sinkholes, as I mentioned at the beginning, on a canal made of earth, but also that is sometimes not really considered by the clients, is that the membrane has a very low friction coefficient at the surface. So we're talking about a manning coefficient of 0.012, like a very smooth, brand new hydraulic finishing concrete, or even quite close to a steel lining. So the membrane is a smooth surface that can both reduce the water level and increase the freeboard for safety reason, or at the same water level with the same freeboard, increase the discharge, provide more flow, and potentially produce more energy. Site C has been a very interesting project that we completed just 1 year ago. In this project, I want to mention Site C because we had to install seven layers of geosynthetics to fulfill the expectation to resist the burst of the geomembrane due to opening of a crack in the foundation, a very sensible clay, a glacial till, and resist the burst required to have several layers for providing low friction, so distribute better the stresses on a larger surface, support, so with a technical textile, puncture resistance with a non-woven geotextile, protection with another non-woven geotextile, two geomembrane, and in sandwich, a geodrain. So it's a confined drainage system in a way that if you have a perforation of the first layer of membrane, the water will not go dispersed into the ground, but will go into the geonet forced by the presence of the second membrane, the secondary membrane. So it's a sandwich designed to prevent any drop of water to go into the formation of such a sensible infrastructure. Repair of La Rona Canal is, we're proud of this because we managed to complete in just 7 weeks the installation along 6 kilometers of canal for 175,000 square meters of geomembrane, managing more than 300 workers with a partner. Tekapo Canal, in a very seismic area like New Zealand, has been made is a rehabilitation project of an earthfill canal where we installed the liner on the full cross section, and the bottom and the shoulder have been protected with rip wrap.
Senhora do Porto Canal in Portugal, the membrane has been installed to rehabilitate this concrete canal, and we had the unique possibility here to measure what was the increase of flow capacity of the canal, also measuring the freeboard, and to estimate the manning coefficient of the geomembrane that I said is about 0.012. So, because of this, the capacity of the canal increased of about 90%. We wrote an excellent paper with the help of Jose Valle here with us about this case. Another project, rehabilitation project I want to go quickly mention to you is the use of mattresses. This is something that Carpi's patented, and we are developing right now to find the best configuration of the connecting zip, the best in terms of performance and resistance to an irregular subgrade. But the principle is to have a mattress filled with concrete, so with a double membrane and in sandwich concrete, panels of membrane or mattress connected by a watertight zip, and this is very suitable for navigation canals where there is the need to protect the membrane by the impact of the boats. That is not uncommon. The last topic, and I have just 3 minutes and I'm at the end, is the use of a membrane in hydraulic tunnels. This is my opinion, is one of the most interesting because actually, of course, waterproofing of dams is fascinating, but installing a geomembrane in a pressure tunnel in a mountain with a water speed, like recently in Elms Tunnel in the USA, that can be more than 10 meters per second, is really a brave installation requiring a very competent knowledge how to manage the loads transmitted by the water, how to manage the drainage of the geomembrane, and how to manage the folds and wrinkle in the liner, because in this application is paramount to have a very smooth surface, to have an extremely competent anchorage system to resist more than 10 meters per second water speed, amazing. And also in case of the watering of the tunnel for maintenance, for instance, a plant outage, a large quantity of water can infiltrate back behind the membrane from the mountain, from the water table, and cause the membrane to uplift. So handling the leakage is paramount in this case to avoid serious damage of the liner. The common cases, we have done 2 projects recently where the membrane has been required to prevent hydrofracturing. So a new construction, including a geomembrane in the design. But typically we are installing the geomembrane in tunnels for rehabilitation. And hydrofracturing unfortunately already occurred. So the membrane is used to stop losing water, to bridge the cracks, the small parts of the concrete lining, and to stop leakage, to prevent further hydrofracturing. Here, the dynamic force of the water is tremendous. The energy transmitted by the water in a potential damage through a hole, through a defect of the membrane is very high. So the anchorage, as you see, is designed with a very close spacing. And we use button plates, metal profiles, and an installation technology, a process of installation, very scrupulous to prevent the formation of folds and wrinkles. So, for example, the case of Bajoli Oli in India, you see in the top left picture the quantity of water through the mountain causing landslides, causing evacuation of villages, and also blocking the roads coming out from the mountain because of the big cracks into the concrete lining and the hydrofracturing of the existing lining. So membrane has been installed with a water against a water velocity expected during operation of 3.3 meters per second with 12 bar of pressure, and we needed to install 14 anchorage lines. The valves that I mentioned to you are in the center picture. Is a very important device. They are bolted to the concrete lining. They are installed on the bottom and the invert of the tunnel. They are designed, this is not in the market. It is a design of Carpi specific for hydraulic tunnels. We designed this valve, and we have a supplier that is making this valve only for Carpi. They can stay sealed during operation, so no water can infiltrate through the valves, but they open up in case of subpressure, especially during the watering. Repair of Elms was really challenging this year, and the client allowed only to test the membrane on a very short section. If we will succeed to convince the client on the performance of the system after 2 years of operation. I'm very confident actually. The client will ask to line 10 kilometers of a tunnel with the same technology that you can see requires a very competent anchorage system with multiple fastening lines, 21 fastening lines, to retain a potential transmission of kinetic energy of a flow velocity of 12.5 meters per second. That is very challenging. Under 60 bar, 600 meter of water pressure in the middle of the mountain. Thank you very much for your attention.